Hello, this is Mr. Moore, and I'm recording a little bit of information on how to solve absolute value equations and inequalities, and how to graph absolute value equations on a Cartesian plane. Let's walk through this, and I'll start by sharing my screen here. Why did that not work? Share. There we go. All right, I have a whiteboard up in front of me here, and I'm just going to move some screens around so we can see everything we want to see. And let's say I want to solve a general absolute value problem. Something like absolute value of x minus 4 equals 2. So I'm going to start with a shortcut way to do it. I'm going to show a more detailed way to do it. And then I'm going to show yet another shortcut way to do it. The shortcut way to do this is we're going to start off by saying x minus 4 equals 2 and x minus 4 equals negative 2. That's because absolute value makes this entire thing positive. So absolute value of x minus 4 can be 2 or negative 2. Actually, it's more accurate to say negative x minus 4 equals 2. There's a reason I write it that way, but if it's an equality, you can write it either way, make either side positive or negative. I'll talk a little bit later about why this first method is better for inequalities. We're going to solve these separately. We have x equals 6 and x equals 2. And so the solution can be written as x equals 2 or 6. There are two possibilities. If I plug in 6, the absolute value of 6 minus 4 equals the absolute value of 2, which is 2. And if I plug in 2, the absolute value of 2 minus 4 is the absolute value of negative 2, which is still 2. Let's go into a more complicated version of this. So another way of saying this is saying that if x minus 4 is greater than or equal to 0, then x minus 4 equals 2. Or if x minus 4 is less than 0, negative x minus 4 equals 2. And so we go through this, we get the solutions just like we did before. Here we have x equals 6. Here we have x equals 2. And we have to make sure that these answers meet these requirements. In this case, 2 minus 4 is less than 0. That checks out. In this case, 6 minus 4 is greater than or equal to 0. Also checks out. So those are solutions. Let's try a slightly different one here. Let's say I have the absolute value of x minus 4 equals negative 2. Now, what I want you to do is realize, hey, the absolute value is always going to be positive. So this has no solutions. And I want you to just be able to say that without thinking about it. However, if you didn't immediately see that, this is the null set symbol right here. If you didn't immediately see that this has no solutions, which I recommend, you want to see that has no solutions, you can write this out just like we did before. I'm going to copy all three of these and paste them down here. But in this case, if x minus 4 is greater than 0, then x minus 4 equals negative 2. And this one equals negative 2. Here we get x equals 2. Here we get x equals 6. But we have to check the condition. 2 minus 4 greater than or equal to 0? No. So no solution here. There is no solution for this where the absolute value is positive and it solves this equation. How about over here? If I plug in 6 minus 4 less than 0? No. So this is another way to see that we get no answers if you want to be really formal about it. One more thing I want to show, and that is the fastest shortcut. Absolute value of x minus 4 equals 2. Just take the thing that makes the absolute value 0 and then plus or minus this number 2. And that will give you the answer. Whatever makes this 0, plus or minus that, as long as the coefficient of x is just 1. And that's another way you can solve these equations very, very quickly. Let's try an inequality just for a moment. Let's say we have the absolute value of x minus 4 is greater than 2. Now, it's important that we write this out the way I mentioned before. I'm going to say that x minus 4 is greater than 2, or negative x minus 4 is greater than 2. Those conditions still apply, but we're going to use another technique here. If we have an absolute value greater than something, you're going to have the parts on the outside. It's going to be two separate groups, x less than some number and x greater than some number. On the other hand, if we had absolute value x minus 4 less than 2, stand by. This one is going to have answers between two values. I'm going to draw that out on a number line here. Let's get a number line. Here's our number line. And the one in red would be the one on the left, from here down, and from here up. The one in green would be the one on the right. And this would just be between two values. In this case, that's this one. And this other one here is the red one. Okay, so let's solve these two equations. We get x greater than 6, or don't forget to flip the direction of the sign. X minus 4 is less than negative 2, x less than 2. So when we graph this, we have x less than 2 or x greater than 6. On the other hand, if it's this type, it's going to be and you're going to have both be true. This one here over here is or if it's absolute value greater than a number. Let's try one more where we want to graph something. Let's say I want to graph on a Cartesian plane. I want to graph y equals absolute value of x minus 4 plus 1. Well, the first thing you want to do is find the thing that makes this absolute value 0. That's going to be called the vertex. What number does that? 4 does that. I can make a table of x and y. If x equals 4, y equals 1. And then go just one to the left and one to the right of that. If I plug in 5, 5 minus 4 is 1. We get 2. If I plug in 3, 3 minus 4 is negative 1, but the absolute value is 1. 1 plus 1 is still 2. So I can plot a point here at 4, 1. 1, 2, 3, 4, 1 right here. I'm going to draw lines in two different directions. The first one has a slope of 1 going forward like this. The next one has a slope of negative 1 going backwards like this, going through those 2 points I mentioned, 3, 2 and 5, 2. This is, I said equal to. I'm going to say greater than, because I wanted this to be an inequality. If it's inequality, I just graph that line. If it's an inequality, well, now it's all the y values that are greater than this. Remember that y is on the vertical axis and x is on the horizontal axis. So what are some numbers that work? Well, we can say 4, 1 doesn't work because it's right on that line. So we have to change this line to a dotted line, meaning that line isn't included. But 4, 2 works, and 4, 3 works, and 4, 4 works. Anything greater than this. So we would shade in this whole area above that. And I'm going to do this. Change this to a gray, and that, and like that. And this whole area up here would be the solution. Y greater than the points on that dotted line. And that's how we would graph this equation. Any equation where you have a variable greater than the number, it's going to be all the y values above it. Less than will be the numbers below it. So find the vertex, go 1 point to the left and right, and draw the 2 pieces of the line where the V happens right at the vertex, at the bottom or the top of that function. It would only be the top if we had a negative in front of it, such as, for example, y equals -2 times x minus 4 plus 1. Here it would be pointing down because the -2 flips the whole thing over. Hope this helped.